In the vast cosmic arena, chaos reigns supreme as stars unleash a mesmerizing symphony of destruction and creation. Get ready to embark on a cosmic roller coaster ride that will leave you in awe of the magnificent chaos that dwells among the stars. Buckle up, stargazers, for we are about to witness 10 astonishing acts of stellar chaos that will ignite your imagination and forever change the way you perceive the universe. Stars make almost all the matters we enjoy today, so you could say they're important. Either by exploding in nuclear hellfire or by smashing into each other, various stellar bodies created the elements that make the internet, and the people who invented the internet, possible. Stars do all sorts of crazy things. Like belch massive clouds of gas, outshine entire galaxies in a second, eat their companions to regain life, and bend the laws of physics in other awe-inspiring ways. Here are 10 amazing acts of stellar chaos. 1. A star belches before it explodes. Supernova usually fade after weeks or months, but fast-evolving luminous transients, FELTs, flash in the pan and then disappear in a few days, like the 1.3 billion light-year distant KSN 2015K, which went off 2.2 days before reaching peak brightness and then faded away after 3 weeks. This is just 1/10 as long as would be expected from a type Ia supernova, whose newly gained radioactivity gives it a brilliant glow. But a year before KSN 2015K's kaboom, it released a puff of gas or stellar belch. When it finally exploded, its ejected star guts slammed into the spreading Burt cloud and lit up the sky with a quick but magnificent flash. 2. A magnetar releases a slow gamma-ray burst. In the early 1990s, astronomers spotted a stupendously bright radio source that rivaled the strongest in the universe. The mysterious signal then faded over the next 23 years. It was the first discovery of an orphan gamma-ray burst, GRB, or the afterglow of the baddest explosions in the cosmos. Regular GRBs last about a minute and are thought to occur as neutron stars or black holes collide, or as stars collapse into black holes. But this long-duration event shows that a GRB can also happen at the other end of the time spectrum. 3. A neutron star spins 716 times a second. About 28,000 light-years away in the constellation Sagittarius resides a globular cluster called Tarzan. Hidden inside is a neutron star that spins 716 times per second. In other words, this thing that's approaching the mass of 2 suns, all squashed down into a ball 32 kilometers, 20 miles across, is spinning twice as fast as your blender. The 716 Hz neutron star, PSR J1000, 748 2446 AD, is at its size limit. If it were any larger, its insane spin would fling pieces of itself into its orbit. 4. A white dwarf revives itself by eating its friend. X-rays can be soft or hard. Soft ones require several 100,000-degree gas, but hard ones come from cosmic furnaces that achieve tens of millions of degrees. Now weird supersoft X-rays are coming from a white dwarf. Fusion was one possible explanation, but ASASSN16O isn't fusing anything. Instead, the X-rays are probably produced by the impact shock of matter as the white dwarf siphons material from its partner star. It will continue to gorge on its sibling until it overeats and supernova stars to death. 5. A neutron star scorches its companion. Neutron stars can only become so massive, but astronomers have recently discovered a body that pushes these specs. The former most massive neutron star, PSR J0348 plus 432, weighed 2.01 solar masses. The new PSR J2000, 215 plus 5135, is a millisecond pulsar, an ultramagnetic, rapidly spinning neutron star. And it has a cute little companion star of only 0.33 solar masses. They're so close that they swing around each other in just 4.14 hours as Big Brother PSR blasts its tiny buddy with intense radiation that leaves one side in the constant shade and the other glowing with radioactivity. 6. A star births its partner. Researchers found a disk around star MM1A. They looked inside and found not planets but a whole baby star, MM1 bit. By analyzing the frequency of light from the disk and measuring the radiation, astronomers ascertained that MM1 is an impressive 40 solar masses, while fledgling MM1 bit is a measly half a solar mass. That's some discrepancy. It probably occurred because the gas and dust disk was too massive, and its beastly gravity tore it into fragments. But the big MM1 is so beefy that it ensures a short lifespan for the entire system because massive stars live short lives before exploding magnificently in supernova. 7. Stars with brilliant comet-like tails. Comets streak across the sky, and some stars do the same thing on a larger scale. Like the giant, ultra-hot stars in Westerland 1, a 12,000 light-year distant stellar cluster inside the Milky Way. Comets earn their tails when they're hit by the solar wind, the stream of charged particles blasting from the sun. So they always stretch away from the sun. Star tails behave similarly. But they stretch away from the center of the cluster as they're pulled like cotton candy by the intense radiation from the many supremely brilliant adolescent stars. 8. Stars that pulse mysteriously. Blue large amplitude pulsators, BLAPs, are odd stars that don't behave like their friends. Instead, these BLAPs are smaller than their blueness would suggest. Crazier still, they rapidly dim and then brighten. A gravitational lens survey has picked out about 12 BLAPs from a litter of about 1 billion observed stars, and they're unlike anything else. As they pulsate, they vary in brightness by up to 45% and do it all on periods of 20 to 40 minutes. That's the equivalent of the sun freezing and then boiling us, all during a standard-length TV show. 9. A dead star gets a halo. Neutron stars blast out X-ray and radio emissions, so those are the wavelengths that researchers observe. But a weird new neutron star, RxJ0806.44123, is so mysteriously hot that it's emitting a significant infrared signature out to 200 AU, or 5 times the average Sun-to-Pluto distance. And it's probably a sight to behold. The unexpected heat could be from a giant disk of material that was thrown out by the supernova explosion and then fell back in around the neutron star. 10. Supernova that doom entire clusters. Star clusters gradually break down as material seeps away, but scientists have found a more sudden, violent mode of dissipation. A neutron star can find itself speeding away through space at hundreds of kilometers per second after being booted from its gas cloud. Simulations show that even though neutron stars only account for 2% of a star cluster's mass, this natal kick can provide the impetus for a cluster to break apart 4 times faster than normal. So these tiny but massive monsters can dictate the future course of innumerable stars and groups of stars throughout the universe. As we arrive at the electrifying conclusion of our cosmic journey through the realm of stellar chaos, we are left astounded by the sheer spectacle and turbulence that unfold among the stars. From the cataclysmic explosions of supernova to the mesmerizing dances of binary star systems, these 10 astounding acts of stellar chaos unveil the true power and dynamism of our universe. If you found our video informative, kindly subscribe to our channel so you won't miss out on our videos.